Okay, let's go on to problem B. This problem statement is a little bit more tricky. So you're given an integer n, let's say n is 5, and you're given an integer k, let's say k is 6. And so basically you want to imagine an array of, or like a thing with 5 spaces, and then you have two people. You have A, which I'm gonna do in red, and you have B, which I'm gonna do in blue. So what red does is it starts at the back, and blue starts at the front, and then at each time, so like this is at time 0, and sorry, at time is 1 since they index from 1, and then at each step, B moves up and A goes back. And then let's do it again. A moves back, and now B wants to move up. But so B wants to go here, but the problem says that A always has priority. So because B wants to go in the same space as A, it skips A and then it goes here. And then this continues. And then I'm just going to keep simulating this process one more time. So A moves back, and then B wants to move up, but because A is here, B wants to go here, and so on. And the problem wants you to find where B is at time k. And yeah, that is the problem. So the first thing to notice is that let's say that there's an even amount of slots. Right? So A starts from the back and B starts from the front. Let's just simulate. So like B goes here. So like after 2 time stamps, both of them move back here. And then now they're going to keep on going without ever colliding. And in general, if n is even, then there are no collisions. So you can just calculate where B is at time k. So that is a little bit tricky because the array is 1 index instead of 0 indexed, but it turns out to be this formula. So I call this position after k steps of an array of size n, and then what that turns out to be is k mod n if k mod n is not equal to 0, and n if k, or yeah, n if k mod n equals 0. Yeah, so the answer is just the position of k and n, if n is even, because there are no collisions. But now let's consider the case if n is odd. So let's go back to our n is 5 example. All right, if you just think about where the collisions are. The first collision was here, and the second collision was here. So and like we showed, and like we went through this last time. And so if you just keep on simulating it, you'll find that the next collision is here, and then the collision after that is here, and then the collision after that is here, and then the collision after that is here. Yeah, so you'll notice that in general, there's a collision after every n over 2 like integer division, so floor of n over 2 slots, or after n over 2 steps, right? And so basically, you can just use this to, so like after some k, there's going to be a predictable amount of collisions, and then you just add that to k, and then you just do the position. You just call the same position function we had for even. And so to find out how many collisions, or the way you do it is that given k, what you do is you find the number of collisions, right? And what is the number of collisions? The number of collisions is what basically it's just k minus 1 over n over 2. And then you can verify this yourself by looking at this pattern that we did. And so now the answer is just the position of k plus num collisions n. Yeah, and so this is basically the way to solve this problem. And I can show my implementation. Q2. Yeah, so 2 cases. If n is even, I have this. I call this position, but I call this calc location here, and this is basically just implementing this formula. And then if n is odd, first I find the number of collisions. I call this unit size for some reason. Yeah, or like the number of spaces here is the number of collisions, and then I just call calc location. Yeah, that's basically it.